Welcome back to our conversation with Brian Spears, the director of the AI Innovation Incubator at the Lawrence Livermore National Laboratory, and Judy Hill, a computational science leader and leader of the Labs Grand Challenge at the Lawrence Livermore National Laboratory. Judy, you mentioned, kind of building that talent pipeline. We always talk about it here. And you mentioned the internships, but is there anything else that you're using in terms of strategy to build that pipeline?
So, NNSA has an academic alliance program for that is helping to fill our pipeline. Here at Livermore Computing, we do offer these internship programs that are very key to bringing in our early career staff. And then we do a lot of collaborating with other national laboratories, sharing experiences. This field moves very quickly. Brian alluded to it in terms of how much the field has changed in terms of energy efficiency. Algorithmically, things have changed. The applications of interest continue to evolve. There's a lot of collaboration to ensure that our people stay current, and as the field moves, that we move with it as well. So it's both bringing in people, but also the people that we do have, retaining them and ensuring they stay at the forefront of the field at the same time.
Yeah, I'd like to comment on the building out of the workforce. We're quite strategic about how we do that. And right now we face two central issues that we care about. One is curating the staff that we need to work in our areas so that we can bring them on as undergraduate students, graduate students, postdocs, and then full-time professionals. And we build out that pipeline through collaborative projects with universities. But we're also incentivized to make sure that university professors themselves are not only building out laboratories and systems that can build that pipeline, but that they themselves are working on problems and research that's of interest to us for national security purposes. And there's a central challenge in the United States right now. Computer science and computational science fields are missing the access to the large high-performance computing they need for both detailed science and for especially AI workloads. So if you are a professor in US academia and you want to work on transformational AI and publish in the most important conferences, you need tens of thousands of GPUs. And the places that you can get that right now are Amazon and Microsoft and OpenAI. So you pretty much have to have a joint appointment between your academic institution and your private partner. And that changes the incentives that academia is working toward. We offer partnerships where we bring tens of thousands of GPUs and those tens of megawatts of power to bear, but we're thinking about it from the public conscience perspective. So we can build partnerships with our university partners, show them an alternative direction. We love our private partners, but we can have public resources available for building that out. We do it with partners like the University of California system, where we have an effort that's called AI at Scale. The professors can work with us to see what the future looks like, that over-the-horizon scanning that we can do, and then they build out university pipelines where students are getting a taste of not only what it means to work at scale, but what national security science problems feel like in the national interest. And so we build out our federal capability to go do those kinds of things that the universities can't ordinarily do and that the nation is required to be able to do.
That's really exciting. One thing that I wanted to go back to is we talked about it a little bit, but El Capitan, I know you can speak a lot to it, but it's a huge deal. So my understanding is that it's ranked as the world's most powerful supercomputer, right? Okay. Could you talk a little bit about that and also its promise for AI? And you touched a little bit on it, but could you elaborate?
Yeah, Judy, take a swing first.
Okay, I'll start with what El Capitan is, and then I'll toss it to Brian for the AI component. El Capitan, as you said, is the world's most powerful, fastest computer as measured by the HPL benchmark, as measured by a single benchmark. That is a very exciting outcome for us. But what's more exciting is the work that's going to be done on El Capitan. So all supercomputers that choose to measure themselves by this benchmark submit their results to the top 500, and then they come out with this list. El Cap was number 1, Tuolumne was number 10. In terms of what it enables, El Capitan is 16 times more powerful than Sierra, our current flagship system. And so in theory, that should allow us to explore problems at higher resolution, to potentially look at a much enable more physics in the problems that we're interested in, the types of national security problems that we're interested in, and as well as bring in new physics to our models themselves. Brian's going to tell you all about the great AI capabilities that it's going to enable, but I think it will enable both AI, but also additional new frontiers in terms of modeling and simulation.
Yeah, I mean, Judy set it up just perfectly. The special thing about Tuolumne and the bigger version, El Capitan, is that we can do two things at the same time. We can think in detailed about solving the fundamental equations for science and engineering that we need for national security problems. And then we can accelerate that with AI in a way that we can't for lots of other systems. So what we do as design physicists, that's what I might have called myself, people who think about how to design fusion implosions to make them work in the real world. What we do is think about what is the best place in some abstract space to set up a simulation. So if I'm thinking about a fusion problem, I want to think, how thick should my target that I'm going to shoot be? How bright should my laser be as a function of time? How much energy should I put on that target? I have to make all of these choices, and those choices set up a mathematical space. Somewhere in all of those dimensions is the place where I want to plant my flag and say, this is where I do my simulation. This is where I will run my experiment. When you look at that vast space of many, many choices, you either have to choose how to do that as a human, and as a human, I can think of 4 or 5 choices at a time. With AI, I can have agents that help me think about not 4 or 5 choices or dimensions, but 10 or 100 or 1,000,000 at the same time. And so what we do is keep that high precision capability to simulate exactly what's going to happen in the real world. And the computer like LCAP is fantastic for that. But then our AI system can look at that landscape and say, okay, I'm starting to understand there may be high value real estate in this space, not only here, but maybe over there and over there and over there as well. And then we can branch off and run with this enormous supercomputer those interesting probes of simulations in detail in all of those high value real estate locations. So we've got both the detailed simulation where we can say what's going to happen at this point. We can go find out how valuable that answer is. And then we've got AI self-driving, if you will, that can help us go identify all the other places that we want to go to do those simulations. And then from the collection, we can say, here's the very best space to be for an open science problem, a national security problem, or any kind of science that we can tackle.
And I have to follow up on how are ethics considerations coming into the space?
Yeah, we think pretty deeply about that as well. We use our AI systems on high consequence missions. These are places where it's not okay to get an 85% correct answer. We're going to be right 99.99 repeating percent of the time. And so we will, first of all, make solutions that have really very little to do with AI. They are all of the guardrails and the containment around those systems that we will use to make good decisions. They are scientists and engineers who have decades of experience and intuition, highly formalized procedures and understanding about what has worked in the past, verification from high performance simulation that's solving explicitly equations that we know to be true. And then there are the AI pieces that are helping us accelerate. So we have these wrappers. It's like multi-levels of containment. If you're in a chemistry lab, the way you operate is you put on personal protection equipment, you have a secondary containment tray that you're operating in, liquid is contained in a beaker, you have gloves on. There are all of these layers to protect from an accident happening. That's how we approach using these systems to make sure we get the right science answer. We are also doing that not just in the digital space, but places that we care in the physical space. So we're exploring AI driving in laboratory places where we may do automated chemistry with robots, where we may build advanced manufacturing parts with 3D printers, where lasers are melting and then having metal re-solidify to build up parts layer by layer. And we also will not make mistakes in those spaces where humans or high-value parts are involved. So we're building out an understanding of the way to trust online the answers that we can use there, but we're getting there from that previous sort of set of nested layers. If we know how to do this safely without the AI, so there's a Hippocratic approach where first we do no harm, and then we understand what we can accelerate. We do have the advantage that getting the right answer is often the best way to be safe. And in physical science, we have in the back of the book, quote unquote, the answer. We can look up and see. If we have a model by AI predicts something, we can actually do the experiment to see if that's the right answer. That's not available to the world of self-driving cars, for example. There's no external theory of how it is that a car can navigate safely and not injure people. So what we can do from our place in science is build out policies where we can make hypotheses about what keeps these models safe Then we can test them where we know the answer and can verify it with experiments. Once we understand what safe practices look like, then we can, in some sense, throw those over the fence to the applications for the social or the softer sciences or the other places, and have them learn from that and reflect on it to build out safe policies in that space. So we feel some responsibility, not just because we want to keep our mission safe and correct, but because we think we're also donating knowledge to other branches of AI and other branches of society.
Yeah, no, thank you so much for that. And we are running out of time, but let me shift gears a little bit because I want to cover a couple more things. One thing, Brian, I want to talk about is the AI Innovation Incubator. Could you talk about that, what the mission of AI3 is, and what are some of the current projects that are happening there?
Yeah, absolutely. It's one of the more exciting things that I'm involved with at the laboratory. We use AI3 to do a number of things. First, we identify grand challenges or moonshots that we think are important for AI to deliver transformation for society. So we have three currently, one in fusion research, one in bioresilience, making sure we can handle emerging biological threats, and one in manufacturing, building out accelerated advanced manufacturing capabilities to transform US competitiveness. So we identify those moonshots. Then we go out and we build public-private partnerships to help us deliver. We can do almost anything at Lawrence Livermore National Laboratory, but we can't do everything. We need private partners to help donate their knowledge to our cause, just like we do to theirs, so we can advance problems jointly. And then what we do is take those jointly developed solutions and we build out a capability base for our national security science missions, while at the same time accelerating our private partners for greater techno-economic advantage for the general United States ecosystem. So we identify moonshots, we build out our capability base with private partners, accelerate national security science, and then build out the private partner techno-economic competition. Some of the things that we have running right now are quite exciting. We have models from OpenAI running on supercomputers with our TriLab partners. They have one called Venado, which was a great target of opportunity to field an OpenAI model. In that partnership, we've come together with OpenAI to take their flagship model, which is at the leading capability of AI in the world, and put it in a classified computing space where we can work on very challenging but also secure missions. We've not previously had access to that kind of capability in the secure spaces where we can go do both our high performance simulations and then ask an AI model to help us navigate that space, as I referred to earlier. So those kinds of partnerships are building capability. We have a similar thing with Meta. With Meta, we are building out a generative AI-driven open polymer database. This database is going to be a catalog of hundreds of thousands to millions to potentially tens of millions of polymers that the world has not yet seen. That between our expertise at Livermore and some partnering capabilities from Meta, we are able to generate this brave new world of polymer chemicals that we need. For example, polymers that do not have fluoropolymer pieces. Fluoropolymers like PFAS are quote unquote forever chemicals that are damaging to the environment, damaging to humans. We have them almost everywhere, including in components that are critical pieces for national security systems, and we would like to get rid of them. So we're working with our partners to build out capabilities to get rid of those kinds of things. That can be part of a moonshot in manufacturing. How do you build out new things quickly with materials that are bespoke, that have the features you want and don't have the ones that you do not want? I'll end that thought by saying there's a trend, the theme that has developed in our work with our AI partners. Their models have become very, very capable. It's getting to the point where expert PhD users have trouble distinguishing between the last version and the next version because they are getting to the capability that the problems you have to articulate to test them are just that difficult that it's hard for a PhD to tell the difference. Now we are in a place where to fully understand the value of the commercial models, it requires the expertise of teams at the Department of Energy and at NNSA and at Livermore like we have. So we can help them understand the value of their models and define what is the frontier. What are the things that cannot yet be done that those models need to be able to do? And then we can offer those solutions back to them to get better. So they need us to go forward and advance their capabilities. At the same time, we need them to advance those capabilities exactly in the directions that we're sharing. So they can get better because of what we're sharing with them, And when they make improvements, it's in the direction that we need in order to improve for national security science. So AI3's mission is sort of wrapped up in that whole story. Identify these large challenges, figure out a way to solve them that makes US industry better, that makes US national security science better at the same time, and then have both those pieces go forward and do something revolutionary so that the US seizes global advantage and maintains it for the better of the country.
A couple of things. The first one is there what stage are you at with the Meta Open Palomar database? What's the deadline there? And the second one is, what are the opportunities for the industry in terms of how, if they want to engage with you, how can they do that? And also opportunities for researchers.
Yeah, so for things like our partnership with Meta, we are deeply in the computational and partnering mode. So we are sharing ideas, they are computing, we're computing. And so you probably won't see a public announcement about results for some time because our scientists are up to their elbows thinking deeply about how they do this, but making rather rapid progress. In terms of the way that other people can participate, we are open to all comers. There is an open call in the Federal Register from the time that AI3 was launched. People can find us and reach out to engage with us. I will say, though, that we are selective with who we will and can work with. We have to make sure there's a clear value proposition that the United States gets better on the public side by the engagement, and that the private partner gets something out of it as well. So we are happy to listen to all calls and folks that are interested in working with us, but we have a small but mighty team at the laboratory working on it, and we can lean in where we can lean in, but only those places.
If researchers want to collaborate with you, is there a way?
Yeah, it is quite possible for individual researchers to collaborate. The best way would be to contact AI3. You can do that by going to ai.llnl.gov. That will get you to the AI3 webpage. That will get our attention. And then usually at the researcher level, we broker one-on-one relationships. So we find an expert inside the laboratory who looks like the twin to the person outside so they can work on the same project. Or we find a complementary person who is, has needs but is different in almost every way. So they go together hand in glove and they match their external partner, or sometimes something in between. But we can also broker those kinds of individual research engagements. But again, it's ai.llnl.gov, and that gets to us.
Great. And Judy, let me go over to you. And could you talk about the Grand Challenge program very quickly?
So the Grand Challenge program is a Livermore program which grants a large fraction of the compute cycles, the capability of Tuolumne, to Livermore researchers and their collaborators. So this goes back to what Brian was saying about university and other researchers partnering with Livermore scientists. That is one way that external collaborators can also gain access to Tuolumne. So the Grand Challenge program, we run an annual call for proposals internally, where Livermore scientists can also collaborate with external collaborators. They put in proposals, and we allocate time on Tuolumne. So these are allocations that, frankly, are really challenging to get outside of a resource like Tuolumne. There's only a couple other programs in the world that I'm aware of that allocate this kind of capability to basic science on a competitive peer review proposal-driven process. The types of projects that we award typically are projects that are of interest to the laboratory, to a researcher here in the laboratory. So typically align well with Department of Energy mission-driven type projects. So we have projects that are in many of the spaces we've already talked about, simulating fusion, looking at fluid turbulence, so understanding the microscopic detail of turbulence, which is really, there's a stochastic or a chaotic element there. Developing new materials, developing drug therapeutics, understanding how earthquakes go off and what the impact of those are. We have climate science projects, a wide range of projects. It's really a privilege to lead this program because this kind of resource like Tuolumne, we see scientific insights, it delivers scientific insights every single day. And so the laboratory and the nation is really fortunate to have this kind of capability dedicated to really fundamental, basic open science.
That's amazing. And before I let you go, both of you, could you talk about your priorities for 2025, what you're focused on, what's kind of the highest priority going into the year?
I'd love to. My highest priority is establishing a Department of Energy and later government-wide national initiative in AI. We can see from our perspective at Livermore what is the demand for national security science to be accelerated by AI. We can see through AI3 and our private partnerships what is the frontier and the capability. And aligning those two things shows us very clearly that for national security, we have got to do something emergent at scale in the country in order to seize advantage and make sure that someone else does not take that before we get there. So you will hear us from Livermore and across the government saying that the US has got to go now, they've got to go big, and we know the directions to go because of our computing resources like Tuolumne, because of our missions, and because of our partnerships. So 2025, and then into 2026 will be the year of a large government initiative in AI if we are successful.
And similar to that, what Brian talked about within Livermore Computing, my highest priority, we've cited Tuolumne, we've cited El Capitan. They have launched. We have users on those machines. We're going to see great outcomes from the research that is done on those machines. We are already thinking about what comes next. And what comes next, it's kind of foggy in the future in terms of computing power and in terms of what our academic and research partners need. We're rethinking, computing has been on an upward trend. Computational demands continue to exceed even what resources like El Capitan and Tuolumne can provide. We're looking at kind of the future of our center, how we can reposition to bring in new technologies like cloud-like technologies, AI accelerators, what our researchers need in the next 5 years, and positioning ourselves to be able to deliver that for them.
That is so exciting. So much more to talk about. We're unfortunately out of time, but let me thank today's guest, Brian Spears, the director of the AI Innovation Incubator at the Lawrence Livermore National Laboratory, and Judy Hill, a computational science leader and leader of the Labs Grand Challenge at the Lawrence Livermore National Laboratory. Thank you both so much.
Thanks for having us.
Thanks for having us.
Of course. I'm Anastasia Obis, and you're watching Federal News Network. Now let me send you back to the studio for more on the AI and data exchange.